Okay, so the book asks to make these diagrams for 7, 15, 18, and 105. So why don't you do 7? We'll just alternate.
So 7 is a prime, so it just goes down to 1.
Okay.
That's all the diagram is.
Yep.
All right, so that's going to be, that's going to tell you that for any prime, what can you say about the diagram?
It'll just be prime going down to 1.
Okay. All right, so that's not too bad. All right, so 15. Why don't you give that to your brother?
Alright, so 15. The prime factors are 3 and 5, so you're going to have 2 directions. This will be divided by 5, 3. 15 divided by 3 goes to 5, and then both of these end up going down to 1.
All right, so is there anything we could say that's special about 15 that we could generalize to say that any number of this form is going to have a diagram like 15?
Well, if there's a number that's just a product of 2 primes, you'd have your number n, and you could write it like this. You'd have first prime, your second prime, and then 1 down here. Like this.
Okay. Cool. All right. Let's do 18. Go ahead.
Alright. So 18, you can divide by 2 to go to 9. You can divide by 3 twice, get to 6, down to 2. You can divide by 3, down to 3, and then over here gets you to 1. And then you can divide there too.
Okay. So this is similar to the last one. So what twist was added here?
So you just add, this is of the form P1 times P2 squared.
Okay.
Would have this sort of diagram.
All right. Neat. So we're seeing, you guys are seeing the nice generalizations of what sort of prime factorization structure gives you the different diagrams. And
Yeah.
So the last one.
105.
I should point out the one you chose in example 36 was, what form was that? What prime factorization?
So you had, that was a square, you had P1 squared times P2 squared.
Okay. Alright, so now 105. That'll be our last one for the day.
So 105, this one you're going to have 3 directions from the start, because I think 105 is 7 times 15.
That's right. 7 times 15.
So this will be the direction for 3. Let's see. This goes down to 35. 5 divided by 5 gets you 21. Divided by 7 gets you to 15. From 35, this way is for 3. You can't divide by 3 again. So you can go down. It's only by 5 and 7. So 5 will be this way. I'll get you to 7. Both of these you can divide by 7. You go to 3. No. You just divide both of them by 7. They don't go to the same number. This goes to 3. This goes to 5. 15. Goes to 3. This goes to 7. I think that's all the links. These all go like that.
Okay.
Oh yeah, 15 has to go to 5. Oh, so that actually makes a cube when you sort of do it like that.
Okay.
So the form, just having a product of 3 primes, you make this either a cube or a rectangular box, depending on how you draw it.
Yeah, so that's actually pretty neat. So, and you had mentioned if you had 4 divisors, so 4 primes, what do you think that the graph would look like?
I think it would be some sort of hypercube shape.
Cube. Sort of a 2-dimensional representation of a 4-dimensional shape.
Yeah, it'd be pretty interesting. Oh yeah, this is cool. I'm glad this caught your eye in the book. I think this is gonna be a fun project.
Yeah.
Sorry, the project going through this book, which is probably gonna take us, until the end of 2020. So, all right, good work this morning, guys.